Welcome to Education or Knowledge, where our mission is to illuminate the unknown and explore the complexities of the universe around us. Today, we're diving the world of space travel. Our first stop is radiation. In space, astronauts are exposed to various forms of radiation, including cosmic rays and solar radiation. These are not your typical sunburn-causing rays. They are energetic particles that can penetrate the walls of a spacecraft, making them a serious concern for the health of astronauts. Picture this. You're in a spaceship, millions of miles from Earth, and your body is being bombarded by these invisible yet harmful particles. They can increase your risk of developing cancer, and even impair cognitive function. We're not entirely defenseless against them, though. Astronauts adhere to strict radiation protection protocols and use advanced technology to monitor their exposure levels. They live and work within specially shielded areas of spacecraft to minimize exposure. But despite these precautions, radiation remains a formidable challenge for space exploration. It's a constant reminder of the harsh realities of venturing beyond our home planet's protective magnetic field. Next, let's discuss microgravity. In the weightless environment of space, astronauts experience physiological changes that can impact their health and performance. Picture yourself floating in a realm where the conventional laws of gravity are virtually non-existent. That's microgravity for you. It's not just about floating objects and drinking water in bubbles, it's about how our bodies respond to such a unique environment. Extended exposure to microgravity can lead to muscle atrophy or muscle wasting and a reduction in bone density. Astronauts can also experience cardiovascular deconditioning due to changes in blood flow. Now, imagine trying to conduct a scientific experiment or repair a spacecraft under these conditions. It's no walk in the park. To counteract these effects, astronauts undergo rigorous exercise routines and use specialized equipment to maintain their physical fitness in space. Despite these measures, adapting to life in microgravity presents a formidable hurdle. However, adapting to microgravity remains a constant challenge for human space exploration. Finally, let's explore the effects of radiation and microgravity on technology. Spacecraft and equipment must withstand the harsh conditions of space to ensure mission success. The void of space is a harsh and unforgiving environment, where the twin specters of radiation and microgravity pose significant challenges to our technology. Radiation, composed of high-energy particles, can wreak havoc on the delicate electronics that power our spacecraft and satellites. These particles can seep into circuitry, causing glitches or even outright failure of systems. Microgravity, on the other hand, can affect mechanical systems, potentially leading to wear and tear that wouldn't occur under Earth's gravity. To combat these effects, engineers employ a variety of strategies. Radiation shielding, for instance, can help protect sensitive electronics from harmful particles. This can be as simple as a physical barrier or as complex as a magnetic field generator that mimics Earth's natural protection. Redundancy is another key strategy. By having multiple copies of critical systems, a failure in one component doesn't spell disaster for the entire mission. This is why you'll often hear about spacecraft having backup systems. It's a safeguard against the unpredictable nature of space. But it's not all about defense. Advancements in space technology are constantly being made to not just survive, but thrive in this challenging environment. We're developing radiation-hardened electronics, designed to resist the effects of high-energy particles. New materials are being engineered to withstand the rigors of space travel, including the extreme temperatures and vacuum of space. Innovations in propulsion systems are enabling more efficient travel, while advances in communication technologies are ensuring we can stay in touch with our spacecraft, even across the vast distances of the solar system. Despite these challenges, advancements in space technology continue to push the boundaries of exploration. Each new breakthrough brings us one step closer to understanding the vast expanse of the cosmos and our place within it. Every challenge conquered, every problem solved brings us closer to the stars. For in the words of the great physicist Marie Curie, "Nothing in life is to be feared, it is only to be understood." Now is the time to understand more so that we may fear less. As we journey through the space environment, we gain a deeper understanding of its complexities and challenges. We've seen how the invisible forces of radiation pose a constant threat, penetrating spacecraft and impacting the health of our astronauts. Yet, through stringent protocols and constant monitoring, we are learning to safeguard our explorers in this vast expanse. We've also grappled with the effects of microgravity, a weightless world that can weaken the strongest bodies. But through rigorous exercise and specialized equipment, our astronauts are learning to adapt and thrive. And let's not forget the technology, our spacecraft and equipment, enduring these harsh conditions to bring us closer to the stars. Despite the risks, our engineers innovate tirelessly to ensure mission success. Through exploration and innovation, we pave the way for future generations to reach new frontiers and unlock the mysteries of the cosmos.